is Shruti. Welcome back to the channel. If you want to master Salesforce the right way with lead level depth, clean code principles, and real world architecture, you are in the right place. Before we dive into today's topic, into today's deep dive on named credentials and external services, make sure you like this video, hit the subscribe button, and turn on notifications for Codeforce Chronicles. We are all about leveling up your career. And if you want to take your learning to the next level, we have two amazing training programs assigned for you. Live training sessions, admin developer and advanced developer get real-time mentorship, architectural breakdowns and hands-on guidance for rupees 750, self-paced intelligent course. Learn at your own speed with comprehensive high quality deep dives for just rupees 500. Named credentials and external services. Focus. Eliminating hard-coded credentials, securing API handshakes and leveraging low-code integrations. Part 1. The why. Moving away from raw Apex callouts format. Welcome back. Welcome back, everyone. In our last session, we looked at to write Apex callouts by using HTTP request and HTTP response. It's functional, it works, but honestly, it's an architectural and security nightmare if you keep doing it that way in production. Why? Because when you hardcode endpoints or worse, API keys and tokens directly into your Apex classes, you violate the core principle of secure development. If a developer leaves the company or an API key rotates, you have to refactor, reset, and redeploy code just to change a credential string. Furthermore, anyone with view access to the repository or code can see your secret keys. Today, we are adopting a security first and low code first approach. Salesforce gives us a magnificent, magnificent tool set to separate our authentication configuration from your logic. Enter name credentials. Part 2. Understanding the architecture. Before we click buttons in this setup menu, let's understand the architectural pieces. Modern Salesforce breaks secured integrations down into three distinct components. Authentication providers, Auth providers, if your external system uses Auth 2.0 like Google, AWS, or in another Salesforce org, the Auth provider manages the handshake, stores the refreshed tokens, and handles the automated token rotation behind the scenes. External credentials. This represents the protocol and the security keys themselves. It defines how we authenticate. Example, custom header, OAuth API key, and maps who in Salesforce has permission to use it via principles. Via principles. Via principles. Named credentials. This is the public face of your endpoint. It specifies the base URL and links directly to an external credential. In your Apex code or flow, you simply call this named credential. Think of a named credential as a secure proxy. Apex simply says, hey Salesforce, go talk to Callout, my external system. Salesforce intercepts that call, looks up the secure hold, attaches the API key or OAuth token safely and sends it across the web without the developer ever exposing the raw secret in the code base. Part 3. Deep dive live demo setting up a named credential. Let's build one one together. Imagine we are connecting to a mock payment gateway that requires an API key passed in the request header. Create the external credential first. Go to the setup and search for named credentials. Click on the external credentials tab and hit the new. We will name this payment gateway AC. For authentication protocol, we will select custom. Note, if we are using Google's or Slack, we should select Auth 2.0 and link it to uh, an Auth provider. Click Save. Next, we need to add the actual secret. Under Principals, click Add. We'll name the principal admin user. For the sequence number, put 1. Now we add our parameters. This is where we safely tuck away our API key. Parameter type, auth header, name, authorization, value, Badger SK test 51NX, and the value will increase. Step 2. Create the named credentials. Now click on the named credentials tab and click new. Label payment gateway URL, that is the API mock payments. External credentials, select the payment gateway EC we just made. Leave generate authorization header. Check if you're using standard OAuth, but since we are manually adding a custom header parameter, we can save this directly. Trainer note. Emphasize the permissions setup. This is where the students usually get stuck. Crucial. And this is a trainer note to the trainers who are watching my videos. Crucial step. Team. Named credentials respect Salesforce security. Go to your setup, open your permission set or profile, look for external credential, principal access, and grant your users access to payment gateway EC admin user. If you skip this, your integrations will fail with a 403 forbidden error. The magic of external services. No code integration. Writing Apex callouts is great, but what if I told you that we could trigger this integration, parse the JSON response, and update a record in Salesforce without writing a single line of logic of code? This is the power of external services. If the external system provides OpenAPI or Swagger specification, a JSON or YAML file describing what their API can do, Salesforce can read that file and automatically generate declarative flow actions for us. Let's look how this works for us. Let's look at how this works. Go to external services in setup and click new external service. Choose from named credentials. Name it payment sales service. Select your payment gateway named credential and paste or upload the API's OpenAPI specification schema. Click next and Salesforce will parse the schema and says, this API has a method called charge card that expects an amount and a card number and returns a transaction ID. Once you hit save, Salesforce automatically generates the actions under the hood. Now let's open Flow Builder. Look at this canvas. Your admins can now build a record triggered flow on the opportunity object. When the stage changes to closed one, the flow runs drags in the charge card action, maps the opportunity amount directly to the API into the API request input fields, and handles the response, all declaratively, security first and low code first. To wrap up our session, let's review why this pattern is dominating modern Salesforce architecture. Maintainability. If the endpoint URL changes from V1 to V2. You change it once in the setup page. Zero code updates required. Separation of concerns. Developers write the application logic. Admins or security teams manage the API credentials and permissions. Empowering the business. By wrapping APIs in external services, developers unlock business analysts and admins to design their own automated. Are there any questions on how named credentials bridge the gap between secure code and low code automated flows? Now, trainer tips for this module. Tips from me to the students. Common pitfall, which I'm going to highlight. Students often forget to assign the permission set or principal access to their user profile, resulting in immediate callout failures. Make it a point to intentionally show how the error and fix it live. Sandbox versus production. You should understand that the name credentials are metadata, but external credentials store data values that don't copy over blindly to sandboxes, making it safe to point sandboxes to staging endpoints without risking production data pollution. I hope this session helped you. If yes, then please like, share, and subscribe to my channel, Codeforce Chronicles. And see you in the next